just wanted to do a quick video on lesson 4.1, but just only to discuss types of solutions and how to compare between them based on graph and equations. How can we see the differences? So as we all know, and we already discussed this idea in the previous video, that a solution in a system of equation is basically a point that is intersection point between two lines. So once two lines in a system intersect, that intersection point, we call it a solution. And we said that it's a solution because it belongs for both lines. So in this case, this point, the blue point, belongs for this line, and also it's part of also the other line. So I can say it's a solution for both lines. Therefore, there is a solution. So a solution in system of equation means an intersection point, or a point where they intersect, they meet, a point that is valid for both lines, for both equations, makes it true for both. Anyways, the no solution, we also said that they are two parallel lines, they don't intersect, they're not gonna intersect, therefore there is no solution between them. And infinite solutions is basically when you have two lines or two equations that are located at the same exact place. They are literally taking the same location, they are overlapping lines, therefore they have many intersection points, or many points they intersect at, as you can see, all of these. So it's an infinite solution. Now what we're gonna add about what we want to discuss for this video as well is basically the idea of how can I see that in an equation. Like, imagine if we don't have the graphs, how can I tell just by looking at the equation that this is a one solution, no solution, or many solutions? So a one solution, I would like to start with the one solution, because this is a very common case that we are already solving with elimination or with graphing. We can see always that the slope, usually slope of the two lines is different, and it makes sense because the two lines are intersecting. They have to have different amount of sleepiness. So suppose that this is the first line, a second line should be something like a bit not going in the same direction, should be something like maybe different slope, so that they will meet at some point, as you can see here. So they can be both increasing, as you can see here, both of them are increasing and still they intersect. They can be both decreasing, as you can see here, this is one line, this is the other line, both of them are decreasing and they meet here. Or they can be one increasing, one decreasing, so they meet here. Anyways, the whole idea is that the slope must be different, whether it's a positive slope, negative slope, different numbers, they must have different slopes. And the y-intercept, we don't really care about it. It can be different, the same, I don't care. Once the slope is different, then it's a one solution. Okay? So this is how we know the type of type of solution, just by looking at the equations. And what I'm discussing today is only in slope intercept form, because it's easy to see that. Now, in no solution case, basically we said they are parallel lines, and if you remember, we studied in parallel lines lesson that any two parallel lines, they have the same slope. So as you can see, they should have the same slope. So that's a huge difference. So they must have the same slope, but also they should have different y-intercept. We care about the y-intercept. It must be different. Why? Because we agreed that same slope because we want them to be tilted the same amount, so nothing will cross the other, no line will cross the other line's way. So this line is going with the rate of 5, this line is going with the same rate, increasing in the same amount. They're not gonna cross each other's way, but different intercept. This means that I want one of them to be intersecting the y-axis at a different point than the other one, so there's some sort of distance between them to guarantee that they won't meet. There's a huge different distance between them, and they are parallel lines walking next to each other. So the intercept must be different, the slope must be the same. Parallel lines, they should have same slope, different intercept. Okay, so if I asked you to give me another equation that is no solution to these as well, you can tell me again same slope, but another maybe minus 9. So as you can see, since it's a different intercept, same slope, I can say it's gonna be maybe something here, another line that is parallel to all of these. Okay, now the last case, infinite solution, is basically overlapping lines. They are taking in the same exact location, so I'm expecting to see a same exact set of equation. They should have the same slope, they should have the same intercept, they should intersect the y-axis at the same location, and they are both must be same slope. That's in this case, then there are infinitely many solutions. Sometimes you will see some examples, maybe writing the same equation but doubled. For example, instead of y equals 5x plus 4, I can write it as 2y equals 10x plus 8. This is the same equation as this one. It just doubled. So how can I know if it's the same slope? Just divide everything by 2 to have y only. You will see that it will turn out into 5x, and this will turn out into 4, which is the same exact equation. Okay, it can be maybe tripled. So maybe you see it as 3y equals 5 times 3, 15x plus 4 times 3 is 12. Okay, again, how can we see if it's the same exact equation? Just isolate the y, divide everything by 3. You will have y alone equals 15 over 3, it's 5. X plus 12 over 3 is 4. So that's just an example of how, if they did a small, if you received an equation with a small twist, how can you still tell if it's a many solution or not? So many solution should be same in all, slope and intercept. They must be two equivalent equations. They must be exactly the same equations. Okay, they can be tripled, doubled, multiplied by anything, but just they need to be equivalent. Now no solution, we have same slope but different intercept. So as you can see, they are both in the same slope, but they are intersecting in y-axis in different locations. And one solution, they must have different slope, and that's it. This will guarantee that they will intersect. The intercept, I really don't care about it. It can be the same, it can be different, it doesn't really matter. Okay, so this point was already clear here as well. As you can see, the slope here is -1, but here it's 3 over 5. And different slope, then directly it's gonna be a one solution. Here, this equation is doubled. So divide by 2 everything. What will you get? Y alone equals -2 divided by 2 is -1, which is negative x directly, or 1x, it doesn't matter, plus 18 divided by 2, it's 9. This is the same as this one. So -1, same slope. +9, same intercept. Since everything is the same, then it's a many solution. It's literally two lines overlapping in the same location. Now the last case, as you can see, they have the same slope, -1, but the intercept is different. Okay, that's it. So this is why they are having some sort of distance between them. Okay, let's discuss some questions. I think that they are sort of important for this topic. So I'll take maybe this first question here. So here in this question they said that write an equation in slope-intercept form that would have infinitely many solutions with this system of equation. Okay, now this system is not in slope-intercept form, and we all know that slope-intercept form looks like this: y equals mx plus b. Now this one doesn't look like that. So how can I write it as y equals mx plus b? What is it? It's 5x minus 2y equals 8. Try to isolate the y. So I want to try to isolate the y. Have the y alone. Why? Because as you can see in slope-intercept form, we have y alone. Okay? So we have 5x that is positive. We need to cancel it. And we have negative 2, we need to cancel it. First, start with the term that is far away from the y. So remove the 5x by subtraction. So we want to remove the whole term. We're not solving for x. No, we're taking this term, all of it, to the other side. Now we have negative 2y equals negative 5x, and 8 is positive. Of course, we cannot combine them because they are unlike terms, okay? Just keep them. We're just rewriting the problem, okay? Next, what can we do is we need to get rid of the negative 2. Divide by negative 2, everything. Divide by negative 2, divide by negative 2. So now we have the equation is y equals negative 5 over negative 2x plus 8 over negative 2. I just want to I have a lot of signs here. Negative with negative is positive. So I can sort of remove these signs and write down the positive sign. Maybe it's better. Okay. And then here, negative with positive, it's negative. Just to have less signs. Okay. Okay, now I rewrote my equation from standard form. I wrote it as finally a slope-intercept form. Now, why did I write it as slope-intercept form? Because in this lesson, I really prefer to work with slope-intercept form all the time, okay? So that's just a preference. By the way, 8 over 2, you can write it as 4. I'll write it as 4. You can keep it as 8 over 2, it's fine. But I'll write it as 4. Okay? Anyways, now what do they want? They want us to write an equation that has infinitely many solutions to this one. I rewrote this one as a slope-intercept form just to see clearly where is the slope and where is the intercept. Because you know that if I want to write a new equation that has some sort of solutions, I really care about the slope and intercept. I want to look at the slope and the intercept just to decide if they should be the same or different. Infinitely many solution, if you remember, who remembers what is infinitely many solution? They should have same slope, same intercept. You can literally write the same equation. You can write the same one. Literally. And tell me, okay, this is the system. Infinitely many solutions. Why? Because both equations are the same. That's it. Or maybe some girls will tell me, okay, miss, I want to double it. Go ahead. 2y, double the 5 only. So, like, just to double a fraction, to double this thing, 5 over 2, if you want to double it, you multiply numerators with numerators, remember? So you're going to multiply only the 5. It's going to be 10 over 2. Just in case someone will ask why did I do that? Okay? And then double the 4, it's going to be 8. You can write it as this. Maybe someone will tell me, no, miss, I want to triple it. I don't want to double it. 1 second. So just go ahead, triple it. 3y. 3 times 5 is 15 over 2. 4 times 3, it's 12 only. So you can do that, okay? Or you can leave the same equation as I already said. Okay? That's it. So it's very easy, very simple. Now next question is this one. How does the graph of system of equation with one solution differ from the graph of system of equation with many solutions? We already discussed this. As you can see, one solution, they intersect at one location. Many solutions, they intersect many times. They are literally overlapping. Okay? So this can be just a clear conversation. And no solution, they don't intersect. So no solution, they are parallel lines Many infinitely solution, they are overlapping. They are literally in the same location. And one solution, they are intersecting. Okay, like this, parallel lines like this, and overlapping, they are literally overlapping in the same exact location. Okay, now here, copy and complete the table by writing the word same or different to show how the slope and y-intercept of each equation relate to the number of solutions in the system of two linear equations. So if you remember the one solution, the slopes must be different, right? One solution, slopes must be different. So they must be different. I'll just write it as D because it's easier to be written. Okay? Slopes must be different, but what about the intercepts? We don't care, doesn't matter. Anything, it can be anything. Same or different, I don't really care. Different or same. Okay? So infinitely many solution here, who remembers? It was everything should be the same. So all must be same and same. And no solution, they must have different intercept and same slope. They must have same slope because they are parallel. So same slope, different intercept. Now here, Rees states that system of equation has no solution because the slopes are the same. Describe her error. Let's take this problem on the side and work on it. Here. So again, we always prefer to work with slope-intercept form. So any sort of standard form, I don't want to keep it as it is. I want to try to rewrite it as slope-intercept form. So in this case, we have 3x plus y equals -1. I want to try to somehow try to change it and write it as a slope-intercept form, which is y equals mx plus b. Okay, so the y is clearly isolated alone. So I want to try to isolate the y by itself. How to do that? Just move the 3x to the other side. So this term, I want to get rid of it. I want to move it to the other side. One way is just subtract it because it's positive. So y will equal to negative. I can't combine them because they are unlike terms, so I just leave them as they are. -3x, -1. I rewrote my problem as y equals mx plus b. Okay, in this case mine. So the equation, I wrote it as y equals -3x minus 1. It's still the same equation. I only moved this term to the other side. Okay, and the first equation, I'm just gonna write it down, which is the same. I didn't change anything in it. -3x. Subhanallah, apparently they are the exact same equations, which is what? Who remembers? If they are the same in everything, same slope and same intercept, this means that they are infinitely many solutions. So in this case, she said that it has no solution because the slopes are different, because the slopes are the same, sorry. But remember, if you have same slope, you must have different intercept in order to be no solution. But here, we had same slope and same intercept. So you have to pay attention at both in order to decide. She only decided that they are no solution because they have same slope. And that's wrong. You have to look at the intercept. Remember, no solution. What is this? A no solution. They have same slope, different intercept. Okay? Infinitely many solutions. They have same slopes, but also same intercept. So can you see what is making a difference between these two solutions? The many solution, same intercept as well. No solution, different intercept. So you have to look at the intercept as well. Take a look at it and then decide. So she rushed into saying that they are same solution, same slope, therefore no solution. No. Take a look at the intercept. All are the same. Therefore they are what? Infinitely. So she is wrong. Okay. Next question. Describe the error a student made in finding the solution of the system of equation. Okay, so you have this system. Again, we have standard form, we have slope intercept form. I don't like to have this situation. I always like to write my equations all in slope intercept form. So take this equation, y plus 3x equals 9, and isolate the y. Again, slope intercept form is basically the y is alone. Okay, y, because it's y equals mx plus b. As you can see, the y alone equals something. So try to isolate it. How? Get rid of the 3x. So y alone equals, I can't combine them, they are unlike terms, so just leave them. The 9 is positive. This is my equation. I will rewrite it here. Y equals negative 3x plus 9. And this one, I'm just going to write it down. Y equals 3x plus 9. Okay? That's a good question. She said that there is an infinite number of solutions since the coefficients and variables are the same. Now, I can't really compare the equations if they are in different forms. That's why I wrote both of them in slope intercept form, just to see clearly where is the slope and where is the intercept. Before, she decided that the slope is 3 for this equation, which is correct, but she said that the slope is also 3 here, and that's wrong. The slope is negative 3. Okay, so this is wrong. You have to rewrite your equation in slope intercept form in order to see the slope correctly. Otherwise, that's not the slope. That's just, it's not clear. It's not correct. You have to put it in the form that will tell you that, okay, here is the slope. That's why the slope became negative, because you have to take it to the other side, okay? So she decided that they are infinitely many solutions because they have all the same variables, constant slopes, intercepts, and that's wrong, because when you rewrite it as slope intercept form, the slope m will become negative 3, which is different from the other slope, which is m equals 3. And if you remember, once you have different slopes, why is it double E? Different slopes, then it's a one solution. So always, before you compare the solutions, make sure they are written in the same form, in the same proper form. Otherwise, you can't really compare. That's it.